The future is electric. Everything from cars to consumer electronics to renewable energy storage is dependent on our ability to build more and better batteries. Today, lithium-ion batteries dominate those markets, but demand for the critical minerals needed to make lithium-ion batteries is predicted to outstrip supply. That, combined with cost considerations and concerns over energy security, are leading companies and countries to consider alternative battery chemistries.
With challenges around, say, lithium, nickel, cobalt supply, some OEMs have turned to sodium-ion.
Sodium-ion batteries have a similar design to lithium-ion batteries, which means the two can be manufactured using similar methods. Both generate electricity through a chemical reaction and are made up of an anode, cathode, separator, and an electrolyte. But in a sodium-ion battery, lithium ions are replaced with sodium ions in the battery's cathode, and lithium salts swap for sodium salts in the electrolyte. Like lithium, sodium, which is part of salt, needs to be chemically processed before it can become the feedstock that goes into the cathode and electrolyte. Sodium is right by lithium on the periodic table, which means that the two are chemically very similar, but sodium is much more abundant. It's also cheaper. Although still in its infancy, the market for sodium-ion batteries is expected to be worth over $11 billion by 2033. While sodium-ion batteries can't compete with lithium-ion batteries in terms of range in electric vehicles, they do present some unique advantages.
Doesn't use the expensive raw materials. There's no cobalt, there's no copper, there's no lithium, there's no graphite, which is really primarily controlled by China today.
What we're actually going to see is a production natron battery cell that's been fully charged, and actually we're going to drill straight through it with a hole saw, and what we're going to find is it's just going to sit there. There's no safety hazard, there's no fire.
Chinese battery giant CATL recently announced that it would supply automaker Chery with sodium-ion batteries for its EVs. Other battery companies like S-Volt and French-based startup Timat are pursuing similar technology. CNBC spoke to two companies, California-based Natron Energy and UK-based Faradion, about their plans to commercialize sodium-ion batteries and the technology's place in the evolving battery market. Sodium-ion batteries have been around since about the 1970s and 80s, but large-scale development of the technology was abandoned in favor of lithium-ion batteries. But now the technology is getting a second look. Excitement around sodium-ion batteries was reignited after the world's largest EV battery maker, CATL, revealed it was investing in the technology in 2021, with plans to establish a basic industrial supply chain by 2023. Similar to lithium-ion batteries, sodium-ion battery cathodes can be made of different materials, which companies are experimenting with to give their batteries specific properties. But overall, the materials used to make sodium-ion batteries tend to be cheaper than the materials used in lithium-ion batteries.
This cell, about 80% of the cost of the cell is the materials. And if you compare it with the bill of materials for lithium, in volume, you're looking at between 24 to 32% less expensive for the bill of materials for sodium-ion compared to lithium-ion.
Besides doing away with lithium, sodium-ion batteries do not require the use of other critical materials, like cobalt, which has been associated with human rights abuses. Plus, sodium can be found anywhere.
Is hugely abundant. It's not just widely available in terms of the current sources of sodium in sea salt, but it's contained in the crust of the earth around the world as well. Lithium, majority of that is within basically 3 countries: Australia, China, and Chile, and developing to be a handful of more countries, but still hugely concentrated. 70% or so of the current cobalt production is in the Democratic Republic of Congo, and again, the vast majority of that is being refined in China. So these are obviously key bottlenecks in terms of the supply chain.
Another draw of sodium-ion batteries is that they have a longer cycle life, meaning that the battery can be charged and discharged more times than lithium-ion batteries and can operate in a wider range of temperatures.
With sodium-ion batteries, we have a very wide temperature operating range, so down to -30 and all the way up to +60. Also, we've demonstrated capability to go up to +80 degrees C as well. And that again is because of the intrinsic elements of the electrolyte and the materials that we're able to use.
Battery fires have also been an issue that's dogged lithium-ion technology, but experts say sodium-ion batteries will be much safer.
Lithium ion, you always need to have 30 to 40% charge in a battery. That's why when you get on a plane and they ask you to take out your batteries, if you're going to check in a bag, it's for those reasons, because they can become unstable and catch fire. And sodium ion is very unique in that way, that we can ship these at 0 volts, so it's like essentially shipping a bag of electrolyte, not an active battery.
For all of its advantages, the Achilles heel of sodium ion technology has been its energy density, which is the amount of electrical power a battery can store with respect to its mass. What this means is that in order to hold the same electrical charge, sodium batteries need to be bigger and heavier than their lithium counterparts, which can be a problem for EVs, where space is limited. Today, sodium-ion batteries have an energy density similar to that of lithium iron phosphate batteries. Lithium-ion chemistries containing nickel, manganese, and cobalt have the highest energy densities. These energy densities translate to range in electric vehicles. Despite its diminished range, experts say sodium-ion technology has a promising future, and companies are rushing to ramp up production. One of those companies is Faradion, which was founded in the UK in 2011. In 2022, Indian conglomerate Reliance Industries acquired the startup for $135 million.
Reliance's own captive demand is massive. They have the largest oil refinery in the world, moving to renewable energy. They have one of the largest telecom companies in the world with Jio, and they have one of the largest retail businesses in the world. So there's all these power requirements, there's delivery vehicles, there's telecom applications.
The cathode in Faradion's battery cells is a chemistry known as sodium layered oxide and contains sodium, nickel, manganese, magnesium, titanium, and oxygen. The anode is made of hard carbon, which comes from coconut shells or other biomass materials. Quinn says Faradion is initially focusing on producing batteries for the stationary energy storage market. This can include things like providing backup power for telecom companies or storing excess energy generated by renewable resources like wind and solar, either on the grid scale or in individual homes. Next, Faradion plans to expand into the low-speed electric vehicle market. Think electric bikes, scooters, and rickshaws. Heavy machinery like forklifts are also a contender for Faradion's batteries. Faradion installed its first sodium-ion battery for energy storage in Australia in 2022. The company says its batteries are already competitive with lithium iron phosphate technology.
In our production size cells, they're currently at 160 watt hours per kilo, and we've got development activities that are taking us to 190, 200 plus watt hours per kilo.
As it continues to improve the energy density of its batteries, Faradion does see a future where it moves into the EV market, starting with commercial vehicles such as buses and trucks that have more room to accommodate larger batteries.
EV is a more crowded space. It's a much more challenging market. It requires a lot more capital, and there's longer design cycles. On the other hand, because there's so much interest in our technology, it's certainly important to be on their roadmap and to be collaborating with some of those companies, because you do want to be able to have a seat at the table.
The challenge for Faradion now is scaling up production. The company is building an R&D facility in the UK to continue developing its technology, as well as working on expanding production with factories in India.
We're building up pilot facilities to go into the hundreds of ton range, both from the material side and cell manufacturing side, and then also in parallel building up the gigafactories to be able to go up into the gigawatt hour scale per year.
Natron Energy is another company trying to commercialize sodium-ion battery technology. Founded in 2012 in Santa Clara, California as a spin-off of Stanford University, Natron focuses on making sodium-ion batteries using a sodium-rich material based on the pigment Prussian blue.
Prussian blue is a consumer product. It's a pigment. You'll find it in paint, blue jeans, all sorts of things. It turns out that it's also great at storing energy in the form of sodium ions. In general, it is a relatively simple compound to formulate. Any chemical plants with quality control and process control to make high purity material can make Prussian blue.
For its battery cells, Natron uses a sodium material rich in iron for the cathode and a manganese-rich sodium material for the anode.
The anode and the cathode electrodes are deposited onto aluminum foil. similar to what you'd have in your kitchen. The packaging is made of this laminate material that's aluminum foil coated with plastic. In between the two electrodes, we would have some kind of separator, and that separator is effectively plastic wrap with a little bit of silica, so glass dust embedded into the plastic, and that's really about it.
Natron has outsourced production of its electrode material to special chemical maker Arxada in Switzerland. The company is continuing its R&D efforts and runs a pilot-scale production line, where it says it can produce between 100 and 200 battery systems per month. One of the advantages of sodium-ion technology is that it can use the same manufacturing plants as lithium-ion batteries. Natron is taking advantage of this, partnering with Clarios to use part of the lithium-ion battery maker's Michigan plant to begin large-scale manufacturing of its sodium-ion batteries in the fall of 2023.
The beauty of that specific plant is it's sort of medium volume. It gives us an opportunity to prove that we can manufacture these sodium-ion batteries on lithium-ion lines before we then go out and build a global scale plant. But at some point in 2024, next year, we're going to be running this plant at a rate of about 3.5 to 4 million battery cells per year.
The company is not initially focusing on the EV market. Instead, Natron is targeting the data center market, where it says its batteries can provide backup power in the case of an outage. EV fast charging stations are another possible future market. Natron is already testing this application with investor Chevron.
Imagine pulling into the station, there are a whole bunch of chargers there, and all the cars plug in at the same time. And now the power load on the electric grid is enormous. It can be really hard for the grid to support all those vehicle charges simultaneously. And so a lot of station operators are actually moving to a model where they would put big stationary batteries in the station to provide those pulses of power to charge the vehicles.
United Airlines has also invested in Natron and plans to use the company's batteries to electrify its ground operations. Wessel says that Natron has raised about $175 million since its inception from a number of investors, including ABB and Colsa Ventures, among others. Natron and Faradion are just two of a number of companies trying to commercialize sodium-ion battery technology. This, as a number of car makers have already announced plans to incorporate sodium-ion batteries into their electric vehicles. As with lithium-ion technology, China is leading the charge in embracing sodium-ion batteries. Out of the 20 sodium battery factories now planned or already in construction around the world, 16 are in China.
The domination that China has in the current lithium-ion supply chain, there is a risk that that now extends to the sodium-ion supply chain, depending on where sodium-ion cell production capacity is built out. And at the moment, it's looking like China is going to dominate in that too.
Most experts believe that sodium-ion batteries have the potential to act in tandem with lithium-ion technology, alleviating some of its supply constraints rather than replacing it entirely.
10 years out, I think sodium-ion is going to have a very strong position in industrial power and grid energy storage. For electric vehicles, there are going to be certain market segments where sodium-ion is a great fit. The jury is really out on whether or not that's going to include mainstream passenger vehicles. We can see a future in which there could be a lower cost sodium-ion option, and that could be a lower trim line on a car, and it may not have quite the same range, but it would be less expensive.
I think where you're seeing lithium iron phosphate, you'll see sodium ion taking market share. I mean, that lithium ion has a couple of decades head start over sodium ion, so we will certainly be taking market share on that for some foreseeable future.
As with any new technology, success usually comes with scale, which sodium-ion battery companies have yet to build out.
Keeping up with the scale of growth of the battery market is going to be probably the largest challenge for sodium-ion to reach large market penetration.
Still, sodium-ion battery manufacturers remain optimistic about the technology's future.
This is a once-in-a-generation transition from fossil fuels to green energy on a global basis, and sodium ion is going to continue to play a big role with that.